Hello guys, we're going to start lesson 3.5 today. But first, our quote of the day is are monsters good at math? Not unless you count Dracula. Today, we're going to solve a system of equations graphically and algebraically. But first, before we do that, click on Joey and tell him how you're doing today. Here's today's lesson. It starts on page 11 in our packet. So, what we're going to do today is we're going to solve a system of equations using whichever method is of your choice, but we're going to start with these first two, which are multiple choice questions. A little bit strange, right? So first, let's look. It says, which system of equations has the same solution as the system below? So what you're going to do if you have an equation or something like this is you're going to check to see, instead of solving, which we could do, we're first going to check to see if any of the equations over on the right are the same as the one that I'm given. So looking at number one, or letter B, let's look at letter B to start right here. Letter B, I see that the first equation is exactly the same as the first equation over here, right, in purple. Oh, I'm going to highlight that instead of box it in. So my first equations are exactly the same, right? Which means that in order for this to have the same solution, my second equation must either be the exact same equation, which right here, it's not exactly the same, or maybe it's like if this has been multiplied by 2, then everything here would be the same. So we're going to look through. So looking at, I'm going to color this one blue. Looking at the blue equation, to get from 3x to 6x, it would have been multiplied by 2, right? Well, now let's look at and make sure that everything, all of the terms, not just the first term, was multiplied by 2. So let's check. 3x times 2 gives me 6x. Does negative 2y times 2 give me a positive 4? No, this number should be negative if everything was being multiplied by 2. So that means that this is not the correct answer because they are not multiples of one another. Okay. Let's just go up to A because we skipped A before. Let's go up to A and check to see if the first equation, if everything was multiplied by the same number. So let's look. 2x to 4x, everything was multiplied by 2. 4y times 2 is 8y. And 7 times 2 is 14. So that is good. That's not the same equation, right? But it's an equivalent equation. Now let's look at the bottom equation. Was everything either multiplied by the same number or is it exactly the same? So 3x and 3x, those numbers are exactly the same. Negative 2y, and then 5 and, oh, geez. Okay, so this one is not the same equation, so it's not my choice. Let's look at C. Choice C. From 2x to negative 2x, it was multiplied by a negative number. So a negative 1, right? 4y, negative 4y, it was multiplied by negative 1. 7 to negative 7, it was multiplied by a negative 1. So every single term checks out. It was all multiplied by the same number. Now let's look at the bottom equation. They look almost exactly the same, except, this is a negative 5 instead of a positive 5. So C is also not my choice. Now let's look through D and double check that it is the correct choice. The first equation is exactly the same as the first equation in purple that I was given. Now let's look at the second one. 3x to negative 6. It was multiplied by a negative 2. If I multiply negative 2y by negative 2, I get a positive 4y. And if I multiply 5 by negative 2, I get negative 10. So both of those equations are equivalent, so it is choice D. Now let's look at number 2. Number 2 here says, which system has the same solution as the system below? So we're going to do the same thing that we just did. First thing that I like to do is go through, and I'm going to color code these again, and see which equations are exactly the same. So let me just do that. So looking at choice A, the first equation is exactly the same, right? Is my second equation exactly the same? No, it's not. But let's see if we can find a number that everything here would have been multiplied by to get that second equation. So looking at the blue equation, to get from x to 2x, I multiplied it by 2. To get from y to 2y, I multiplied it by 2. And then, oh shoot, this number is the same. It should have been multiplied by 2. So it's not choice A. For choice B, the purple equation is exactly the same. Now let's look at the bottom equation. Was everything multiplied by the same number? From x to 3x, it was multiplied by 3, so that's good. From y to 3y, it was multiplied by 3. From 2 to 6, it was multiplied by 3. Oh, it's choice B because everything was multiplied by 3 in that bottom equation to make an equivalent equation. All right. That is one of the ideas on the delta math, is to make some equivalent solutions or equations that have the same solution. Now we're going to look at this, which is on the back or the next page, page 12. For each equation below, solve the system graphically and algebraically. Make sure you have ask questions when you have them. So first, let's solve them graphically. So to solve them graphically, you would need to get both equations into y equals. So I'm going to make myself a note here. Need y equals to solve it graphically. Okay, so what I'm going to do is take my first equation over here, and I'm going to solve it graphically. So I'm going to subtract an x on both sides. I get 2y is equal to negative x plus 4. Then I can divide everything by 2 to get y by itself. And I get y is equal to negative x over 2 plus 2. Now, what does that mean for my graph? That means that I would start at positive 2 on my y-axis, and my slope is a negative 1/2. Remember, we did this in lesson 1. My slope is negative 1/2. My y-intercept is 2. So now I'm going to go to my next point by going down 1, right 1. Or right 2, excuse me. Down 1 because it's negative, then right 2. Down 1, right 2. Down 1, right 2. And then I can connect these with a line. Now, of course, I'm running out of space. But don't forget that you can use that template from the other lesson to help, okay? And you're going to write the equation of the line, the original equation, x plus 2y equals 4. Now we're going to do the other line, and we're going to have to get it to y equals before we can graph it. So ready? 3x plus y equals 7. Let's get it into y equals. So I'm going to subtract 3x from both sides. Y equals negative 3x plus 7. If you are looking at your equation of your line, your slope is negative 3 and your y-intercept is 7. So you start at 7 on your y-axis. And then if it's negative 3, it means it's negative 3 over 1. So we go down 3, right 1. Down 3, right 1. That's where they intersect. Down 1, 2, 3, right 1. And I can draw in my line. Finish it off with arrows and the original equation, 3x plus y equals 7. So now that I've graphed it, I know that my solution is the point at which they intersect. So at this case, it's the point 2, 1. If I were to do it algebraically, it's up to you whether you do it. I'm going to scroll back up here. To graph it algebraically, it's up to you if you use elimination or substitution. I don't mind which way, but you're going to do elimination or substitution for that one. Okay? So, what I'm going to have you do, that's what you would do over here. Now, you already have a video on those. But going back to your agenda for the day, you do have practice. There's a flip-flop activity on Cami that I'm going to talk about, and then there's 3.5 on Delta Math. So the flip-flop activity on Cami, what that looks like is, well, it's on Jamboard too, but it looks something like this. So I'm calling it Systems Mixed Practice for Coloring Sheet. So what I did was I went through and I did some problems for you to A, cut down on the number of problems, okay? And then B, to give you an example on each slide. So if you go into your Jamboard, on each slide, one of them will already be completed, okay? To give you some examples of what to do in case you need that extra help. But the other thing is that once you finish this, once you finish all of your questions, if you want to, this is the optional part of it. You do have to do the Jamboard, but once you finish the Jamboard, you can go in to this on Cami and color in your picture based on the colors from the Jamboard. Okay?